Hello, my name is Manav.
And my name is Nirvi, and we're presenting some of the findings from our survey on data communication and networking in remote and rural areas.
Importantly, please note that this is an incredibly small portion of our larger work that can be found in the associated paper, which is around 50 pages.
In class, we have predominantly learnt about wired network infrastructure that connects us to the internet. However, having reliable wired infrastructure might not be possible in some rural and remote regions. Hence, we want to explore the way in which the concepts we've learnt in class would be modified to cater to these environments. We also wanted to see some innovative applications that have been used to cater to these regions.
From the papers we have covered, we have observed that the constraints that hinder the development of wired infrastructure in most rural and remote areas can be classified into the following categories. These are geographical constraints, meteorological constraints, economical constraints, and legal constraints. These challenges are also amplified when such regions are affected by natural or man-made calamities. In such times, network services can act as a highly useful tool to save lives. Therefore, efforts must be taken to improve connectivity in such regions.
We classified the papers we mentioned in our proposal into 5 groups. In this presentation, we shall look at the papers under each section and their key findings. Class 1. Exploration of challenges. Here, the main aim was to understand the gravity of the situation of how having a decent internet and telecom connectivity was a basic requirement in this day and age. We also understood the reasons behind why this requirement could not be fulfilled in remote and rural areas. We found that given how limited basic infrastructure is, building a network infrastructure becomes even more expensive in these areas. As a result, more of the children and youth are cut off from the knowledge of the world. One work suggests that in rural areas, mobility is not much as it is in urban areas. Hence, it should not be a major hindrance in developing communication services. However, due to limited infrastructure, the problems of having even a little amount of mobility is aggravated. Still, efforts are being made to improve connectivity, and even those have produced promising results in the growth of an individual in the area. However, the next question arises on how to maintain such networks. Most papers reiterate how it is important to educate the locals about the usage and risks of the internet and how to maintain and upgrade the infrastructure. In some regions, government regulations are not clear, and so it can be deemed illegal to own a business for providing internet services. This forces the general public to rely on foreign companies and organizations and not be self-sufficient.
Class 2. Efforts to improve communication. The basic service of connectivity is communication. Given the constraints mentioned before, we aim to identify various methods that improve connectivity in rural areas. Here have some focus on energy consumption of the network, as they are all aware of the fact that rural or remote areas often have limited energy, which needs to be shared among a variety of tasks. Some even propose to augment energy through renewable means to power the network architecture. Some solutions also propose tiered systems, which allow for clustered deployment of the final tier into clusters of settlements. This allows for efficient use of resources in areas where densities of people varies greatly, as is often the case with rural areas. Some approaches also utilize open source software and off-the-shelf hardware to create modular and easily scalable hardware as per the need. The focus for deployment in rural areas for these solutions is typically to provide basic services like calling and text messaging. More application-based needs are then built on top of that, such as for healthcare or farming. Finally, some papers also arrive at communication from the perspective of economic feasibility and show how even conventional architectures may be economically feasible in rural or remote areas with little to no change.
Regions affected by natural and man-made disasters are usually cut off from the internet due to damages to terrestrial infrastructure and power outages. At the same time, efforts are made to rescue the people stuck in these areas and monitor the extent of damage. This poses new opportunities to find ways to manage the situation without further risking human life. focus of the paper associated with this section was to either augment the existing network architecture of the area using unmanned aerial vehicles or vehicular ad hoc networks or other space airborne devices in the case that the terrestrial network is completely non existent. Most tasks also majorly focused on how to reach a terrestrial gateway from these airborne devices. Innovative ways have been proposed to show where these gateways should be and how to reach them. Other works focus on how to organize the UAVs in space around the area of interest to maximize coverage while minimizing the number of drones. Many papers focus on LoRa technology, which is a low power wide area network technology that uses lightweight devices to provide data transfer over relatively longer ranges. However, this technology in its vanilla form still has limitations which the papers aim to resolve. Smart agriculture. IoT devices are widely used in agriculture, but their performance is challenged when the areas are large and weather conditions are extreme. This pushes us to look into innovative network architectures that provide good connectivity with little loss of energy. Lightweight devices are used, so lightweight protocols are preferred. Since IoT devices are used, these methods also predominantly use LoRa along with a combination of satellite or other gateways to enable collection of data over expansive regions even in poor weather conditions. LoRa on its own is a single hop protocol, but in large remote areas, it would be helpful to have multi hop protocols, and hence, a lot of papers propose SDN based network architectures to enable that. One of the methods proposes modifications of massive machine type communication, MMTC, a type of communication where a large number of small devices are connected to a 5G network, which on its own doesn't perform exceptionally well in remote areas. To use MMTC in such areas, the authors propose to combine it with low Earth orbit satellites configured to LPWAN and modify the protocol accordingly.
Class 5, Wide World of VANETs. These are a bunch of my favorite papers.
And mine.
Vehicular ad hoc networks change the ballgame and present an innovative way to transfer data because it uses vehicles to pass data from one node to another. All rural areas are connected to a city by a road on which there are vehicles. Hence, all regions are physically connected, and vehicles and roads act as the physical medium. Using the same idea, VANET-based infrastructure aims to bring services provided in cities to reach the rural population. Note, which all these papers also consider, is that because we are relying on vehicles to route and transfer data, the transmission has to be delay tolerant. As for what these services are, they focus on a variety of things ranging from healthcare to entertainment. Some of these services are things like patient data collection. In this case, the aim is to collect patient health data, such as oxygen levels, heart health information, etc., and securely with minimal costs while using conventional transportation. The data passes through different networks, and the access points range from devices in wide-body area networks to roadside units, all to provide secure, fault-resistant data transfer. Other papers utilize this kind of network to provide digital content for the purposes such as education and entertainment without relying on telecom operators or dedicated network infrastructure. There's also some interesting results on the performance and transfer speeds depending on different vehicle arrangements. For example, how fast would the transmission to all recipients be if the vehicles were arranged in a line versus if they were arranged in a star? If implemented correctly, these might help reducing infrastructure costs as the device that route the packets are expected to be built on traveling vehicles that are not owned by the internet service providing company. Now, security is an important consideration for VANETs and a major concern for the former application of healthcare, but not explicitly addressed in other application papers, deferring it to security aspects of the existing protocols used.
Due to the expansive nature of our survey, further details about each of these selected papers is mentioned in the report. As was proposed in our deliverables, for each method, we have summarized the network architecture, protocol used, results, applications, and challenges as they pertain to addressing the communication gap between urban and rural or remote areas. Overall, we provide a comprehensive study that highlights the issues with traditional methodologies, restrictions present in rural or remote areas, and how these methods have been put to use to develop innovative architectures to overcome these restrictions.